Hi guys, welcome back to the channel. In this video we are going to discuss 3-bit up down counter in a single counter, 4-bit up down in a single counter. So let's get started. So if you observe clearly, this is the 2-bit up down asynchronous counter. So in between we have 2 cross 1 multiplexer and we have select line that has our own selection line. So if you pass select line as 0, it will be going to select Q0. If you pass selection line as 1, it will be going to select Q0 as our output. So output, if you consider, that is directly connected with the clock of the next flip-flop. So that is the main required thing in this. So with the help of this small circuit, we can have 2-bit counter, that is up and down in a single counter. These are the basic video that first videos asynchronous 2-bit counter explained. So in that video, in detail explanation of 2-bit counter, how it will miss up down in a single counter. That up to now what we have watched. So the second one is the basics of 3-bit 4-bit up counter. So this is just video for 3-bit 4-bit count up and down in a single counter that we are going to discuss. With the help of these two videos, we are going to have this video. But in this video also I will going to discuss in a rough manner. So as select line, if you see that I am passing 0, then it will select as Q0 and it will send to the next flip-flop as that clock. So this is the required thing. So that is the thing that we are going to have the up counting in a 2-bit counter. Using the same principles only, we are going to have the 3-bit and 4-bit up and down in the same counter. So that is the thing that we are discussing the first of all with the help of the 2-bit up down counter. In the same way, if you pass the select line as 1, it will be going to select Q0 bar and it will be passed into the clock as to the next flip-flop. So this is the required thing, that is our required condition if you want to implement the down 2-bit asynchronous counter. That means we are going to pass the Q0 bar directly as clock to the next flip-flop, but instead of passing directly, we are having a multiplexer. So with the help of multiplexer, we have select line. With the help of select line, we can select whatever we want. So if you pass directly Q0 to the clock next to the next flip-flop, that acts as a up counting. If you pass Q0 bar, that acts as a down counting. So that situation, we are going to have single multiplexer to have a select lines. So it is very simple to have a single circuit instead of representing 2 circuits. So this is the 3-bit ripple up counter and the next one is 3-bit ripple down counter. So first one, if you consider, we are taking output from Q0, Q1, Q2 in the next, and the clock is passing from that only. So if you see the second flip-flop, the clock is Q0. If you see the third flip-flop, the clock is Q1. So that's exactly opposite thing, that is the third one. So the clock is passing to with the help of for the second flip-flop, clock is Q0 bar, for the third flip-flop, clock is Q1 bar, but the outputs are same. So this is known as 3-bit ripple down counter. Just a small change, that outputs are same but the clock is changed. So with the changing of clock, whole thing will be changed. It is down counter. So in the same fashion, now we are going to build the 3-bit ripple up down counter in a single counter. So for that purpose, I am going to have 3 flip-flops and in between I am going to implement the 2 cross 1 multiplexer with the select line as M. Means the both select lines are connected to each other. So now we are going to join all of them. So let's see after joining how it will be looking like. Just join with the help of the multiplexers, because we have already saw the 2 joinings with the help of the 2 counter, means 2-bit counter. So if you consider the first flip-flop and second flip-flop, just join as 2-bit flip-flop. If you consider the second and third flip-flop, join as the 2-bit flip-flop, that up to now what we have saw. So join all of them, you can see like this with the help of 2 select lines. So if you want, you can remain like that, and you can join both of the select lines as one select line. Now this is the 3-bit ripple up down, means we can implement up down in a single circuit or a single block diagram. We can implement that up and down counting in a single counter. So basically, as we have saw in the 2-bit up counter, so the same thing that we are going to apply here also. So if you have M is equal, the M means the here select line. If you have M as equals to 0, we are going to select in the first flip-flop, that is Q0. In the second flip-flop, we are going to have the Q1, and the third flip-flop, that is nothing, because the output is Q2 directly there. So in the sequence, we are going to have for the second flip-flop, the clock is Q0. For the third flip-flop, the clock is Q1. So this is simply represents the up counter. So starting from 0 and up to, it will count to 7, and again going to 0, like that it will count. So basically this is the up counter. In the same fashion, if you want the down counting, just select line as 1. So it just represent the reverse one. So the Q0 bar will be the clock to the second flip-flop, and Q1 bar will be the clock to the next flip-flop, means the third flip-flop. Again it will be going to start from 7 and end at 0. Next it will start from 7 and end at 0. So basically this is the down counter, 3-bit ripple down counter. So combinedly this is the up down ripple counter, 3-bit. So basically 2 cross 1 multiplexer means what? It's also basically made up of logic gates. So with the help of the logic gates, the whole circuit diagram would be looking like this. So if you want, you can remember this, or you can have a simple representation of 2 cross 1 multiplexer in between both of them. So I hope I think the first one, or the simple representation of 2 cross 1 multiplexer, is very easier than this one. But remember one thing, both the representation are correct, or both are same, I can say. In this you have elaborated as M and M bar, and you are connected with the two AND gates, and you are joining with the OR, means the AND gate, and finally you are joining with the OR gate. So this is the representation of multiplexer. So if you want more multiplexer videos, you can check out our playlist only, that available multiplexer videos. Or otherwise we can have the truth table expanded form, and we can able to derive this circuit diagram with the help of output expressions. But it's very simple to represent, as it is a 2 cross 1 multiplexer, than representing or remember this whole circuitry. Now we are going to build the 4-bit ripple up down counter. So basically up counting and down counting, it would be in the single counter. So if the 4-bit means just the nothing but extension of 3-bit flip flop, means for the 3-bit flip flop we are going to have one extra flip flop, that is for the counter. So this here we are having 3 flip flops for the counter, 3-bit counter. So just add 1 bit also, means 1 flip flop, that becomes our 4-bit ripple counter, up down counter. So finally, as you seeing there, that is the thing, that is 4-bit ripple up down counter. So we can implement the same logic that we have saw in the 3-bit up down counter. So just nothing but I have added a new flip flop after the last one, and a multiplexer in the last one. So again we have 3 select lines, means the all are M only. So you are going to collect or select all that M select lines at a time, and we are going to select Q0, Q1, Q2, Q3 at a time. So basically this also works as same as 3-bit ripple up down counter. So I hope you can do these things. You can understand this with the help of small adding flip flop. So I hope you understood this video. Thanks for watching up to now.